Welcome my students. In this video we'll complete solving some questions about the two equations of the tangent and the normal, and we will complete starting from question 10. Question 10, the normal to the circle x square plus y square equals 12 at any point on it passes through the point 2 and 2, 1 and 1, 0 and 0, or -2 and -2. To understand this question, first we'll draw the circle here. We have a circle, and what we mean by the normal to the circle. The normal to the circle is the normal to the tangent. So if we draw a tangent here, this tangent to the circle, so the normal to it is perpendicular to the tangent here. When you draw it, it will pass through the point of intersection of the two axes, x-axis and the y-axis here. Here is x-axis and y-axis. So the normal here, it will pass through the point of the origin. Okay, so that's because if here is the origin point, so the normal to the tangent, here is a tangent, this normal will be perpendicular to it. And from here you can determine the length of the radius of this the radius of the circle here. Consider it's r. So this circle in the form x square plus y square equals r square. So r equals square root of 12, which equal to root 3 length units. So we'll choose letter C. The normal to the circle at any point on it, it passes through the point 0 and 0. Again, if you wanted to draw any tangent to the circle here, like this, and you wanted to draw the perpendicular to the circle, it will be the perpendicular to the tangent. Also, it will pass through the origin point and making an angle of measure 90. Okay, it will pass through the point 0 and 0. Next question here. Question number 11. The tangent to the curve y square equals 4ax is perpendicular to x-axis. Then dy dx equals 0, dy dx equals 1, dx dy equals 1, dx dy equals 0. Here we have the tangent is perpendicular to x-axis. So you can consider theta equals 90 degrees. Okay, so dy dx it is the slope of the tangent equals tan theta, which equal tan 90. It is undefined. It is undefined, so you can write it in the form, in this fraction, 1 over 0. That means dx dy equals 0 over 1, which equal 0. So we will choose letter D. Question number 12. the tangent equation to the curve x equals y square at the origin is y equals 0, x equals 0, x equals y, x plus y equals 0. The required here is to find the tangent equation. To find the tangent equation, you must calculate the slope of this tangent. How you get the slope? By differentiating both sides with respect to x. So, by differentiate both sides with respect to x, we will get 1 equals 2y dy dx. The first derivative of x equals 1. The first derivative of y square is 2y dy dx. And from that, you can deduce that dy dx equals 1 over 2y. But here, the tangent equation to the curve x equals y square at the origin. So the tangent passes through the point 0 and 0. It means when x equals 0, then y equals 0. So here we have dy dx equals 1 over 2y. When y equals 0, then dy dx, it is the slope equals 1 over 2 multiply 0, which equal 1 over 0. It is undefined. So the slope dy dx, it is undefined. And the equation of any straight line, y minus y1 over x minus x1 equals m. M here is the slope, so y minus 0 over x minus 0 equals 1 over 0, because dy dx, it is undefined. Cross multiplication, what you get? Here first we'll simplify the left hand side. It will be y over x equals 1 over 0. So cross multiplication, what you get? Y multiplies 0 equals x multiply 1. It means 0 equals x. Or you can write x equals 0, and this is the tangent equation. X equals 0. Here. Question number 13. The two curves of the function f of x and g of x are tangential at the point 2 and 4. And f dash of 2 equals 3. Then g dash of 2 equals, it will be equal 3 also, because they have the same tangent, and I will explain it on this figure. Here we have a function, the curve of the function f of x, and here we have the other function g of x. Okay, now where is the tangent? The tangent here, it will be this straight line like this, and we have this point equals 2 and 4. So g dash of 2, it is the slope at the point 2 and 4. F dash of 2 equals 3. F dash of 2 equals 3. and the two functions f of x and g of x have the same tangent at the same point, so g dash of 2 also equals 3, and we choose letter B. Question number 14. The rate of change of the slope of the tangent to the function f such that f of x equals to x power 3 at x equals 3 equals complete. Okay, first we calculate the slope of the tangent to the curve. And we know that the slope of the tangent to the curve, the slope, first we calculate the slope here. The slope, we write the slope equals dy dx. It is the first derivative. And we have f dash equals 2x power 3. So dy dx equals f dash of x, which equal 6x power 2. 3 multiplied 2 equals 6. And we 3 minus 1 equals 2. So f dash of x equals 6 power 2. But the required here is to find the rate of change of the slope. So the rate of change of the slope equals the second derivative of f of x. You can write it dx of dy dx or you can write it is equal d2y dx squared. So we have dy dx equals 6 power 2. So d2y dx squared, second derivative, equals 12x. When x equals 3, we write d2y dx squared at x equals 3 equals 12 multiplied 3, which equal 36, and we choose letter A. Question number 15. If the tangent to the curve of the function y equals x squared plus a, y equals x squared plus a at the point 1 and b, cross x-axis at x equals -1, x equals -1, then a multiply b. The required here is to find a multiply b. 3 or 4 or 12 or -12. It's quadratic function, and here we have the point -1 and 0. And the tangent passing through another point 1 and b. So I'll draw the tangent here, passing through the point -1 and 0, like this. And the coordinates of this point 1 and b. Now again to the question. If the tangent to the curve of the function y equals x squared plus a at the point 1 and b, crosses x-axis, here we have x dash at x equals -1. The required here is to find a multiply b. We can deduce that y dash equals 2x. Of course, y dash is the slope. It is the first derivative. It is the slope of the tangent, okay? again y dash equals 2x plus 0, so y dash equals 2x. Okay, but the tangent passed through the 2 points -1 and 0, it is given, and 1 and b. So again you can deduce y dash, and now we can calculate the slope using these 2 points -1 and 0, 1 and b, because the slope equals, it is a rule, y2 minus y1 over x2 minus x1. Okay, equals, we can consider 1 and b, x2 and y2, -1 and 0, x1 and y1. So b minus 0 over 1 minus -1 equals the slope. Okay, so it's equal b minus 0, it's b, 1 minus minus 1, it is 2. Okay, it's again y dash. Here we have y dash from the equation of the curve equals 2x, and here is y dash equals b over 2, so 2x equals b over 2. And from that you can deduce that b equals 2 multiply 2x, which equal 4x, cross multiplication. Okay, when x equals 1, we can deduce b, because the tangent passing through the point 1 and b. So when x equals 1, so y equals b. And now we can substitute, so b equals 4 multiply 1 here equals 4. Okay, now we know that b equals 4. So we can say that the curve passes through the point here 1 and 4. Okay, since the curve passing through the point 1 and 4, and from the equation of the curve here, when you substitute y equals 4, then x equals 1. Okay, so when y equals 4, we have 4 equals 1 power 2 plus a, and then a equals 4 minus 1, which equal 3. But the required here is to find the a multiply b. A multiply b equals 3 multiply 4. Here 3 multiply 4, and the result equals 12. And we will choose letter C. Question number 16. The tangent to the curve whose parametric equations are x equals 3 cosine theta and y equals 3 sine theta, where theta is less than or equal pi, greater than or equal 0, is parallel to x-axis at theta equals one of these values. So the tangent is parallel to x-axis. So you can say, since the tangent is parallel to x-axis, then its slope equals 0. So the slope of the tangent equals 0. What that mean? That mean dy dx equals 0. Now, the required here, we wanted to find dy dx from these parametric equations. From here, you can say that dy dx using a chain rule equals dy d theta divide dx d theta. We have y equals 3 sine theta. So dy dx equals the derivative of 3 sine theta as 3 cosine theta. And the derivative of x with respect to theta, it is dx d theta equals negative 3 sine theta. So substituting in this form here to get dy dx equals dy d theta, it is 3 cosine theta, divide negative 3 sine theta. 3 divide negative 3, it is negative 1. Cosine theta over sine theta equals cotan theta. So dy d theta, dy dx here, dy dx equals negative cotan theta. So negative cotan theta equals 0. That means cotan theta equals 0. And tan theta is undefined. Okay, tan theta is undefined. So when cotan theta equals 0, so theta equals 90 degrees, which equal pi over 2 in radian measure, and we choose letter C. Letter C here. Okay, question number 17. Here we have the angle measure that the tangent to the curve sine 2x equals tan y mix with the positive direction of x-axis at the point 3 pi over 4, and the 3 pi over 4 equals one of these values. Here we wanted to find the angle measure that the tangent to the curve makes with the positive direction of x-axis. Okay, so by differentiating both sides with respect to x, what we get? Here we have the equation, and I wrote it already. So by differentiating both sides with respect to x, what is the derivative of sine 2x? It is cosine 2x multiply 2, multiply the derivative of the angle, equals the derivative of sec y is sec square y dot the derivative of y is dy dx. So we can write 2 cosine 2x equals dy dx multiply sec square. So dy dx equals 2 cosine 2x over sec square y, and substituting these two coordinates. Here is 3 pi over 4 To calculate it, 3 pi over 4 equals 3 multiply 180 over 4, and you can calculate it in your calculator like this. 3 multiply 180 over 4 equals 135. So we write 2 multiply cosine 2 multiply 135 over 6 square y, also y here equals 135 degrees. So dy dx equals 2 cosine 270 over 6 square 135, and the cosine 270 equals 0. So the numerator equals 0 over 6 square 135, which equals 0. So the slope equals 0, and we'll choose letter A. Question number 18. Here we have the straight line ax plus by plus c equals 0 is perpendicular to the curve xy equals 1. Then a is greater than 0, b is greater than 0, or a is less than 0 and b is less than 0, or a equals 0 and b not equal 0, or a is greater than 0, b is less than 0, or a is less than 0 and b is greater than 0. Okay, let us check it. First we will find the slope of the line. From the given line here, from the given equation, we have ax plus by plus c equals 0. So the slope of the straight line equals negative a over b. Negative, in general, negative coefficient of x over coefficient of y. So we write negative a over b, or you can calculate it by differentiation. Here we have the equation, and we make the differentiation for it to deduce the slope of the straight line. Here, with respect to x, we have a plus b dy dx plus 0 equals 0. That means b dy dx equals negative a. So dy dx equals negative a over b. Okay, we have also the equation of the curve xy equals 1. So y equals 1 over x. So by differentiating both sides with respect to x, we can deduce y equals negative 1 over x square. It is also equals, it is y dash, okay, equals dy dx. Okay, and also we have dy dx equals negative a over b. So but the straight line is perpendicular to the curve. It means the straight line is perpendicular to the tangent to the curve. So their slopes, the product of their slopes equals -1. So we write -a over b multiply -1 over x square equals -1. Again, because we have the straight line is perpendicular to the curve. What that means? The slope of the straight line multiply the slope of the curve to the tangent. Their product equals -1. Now we can deduce, we wanted to deduce the relation between a and b. So a over b multiply 1 over x square equals -1, because negative multiply negative is positive. Also, we can deduce a over b equals -x square. So always a over b is less than 0. Always negative number less than 0. So a multiply b, ab is also less than 0, and we choose letter D. That means a and b always have different signs, positive and negative, or negative and positive. So we choose letter D. Here is a is positive and b is negative, or a is negative, b and positive. Always the product is less than 0. Question number 19. Question number 19. The length of the intercepted part of y-axis by the tangent to the curve y equals x. Y equals x sine x at x equals pi equals negative pi square length units. Okay, so we have y equals sine x. So at x equals pi, we can deduce the y coordinate. So y equals, substituting x equals pi multiply sine x, it is sine pi, equals 0. Why? Because sine pi, sine 180 equals 0. 0 multiply pi equals 0. Okay, those at the tangent passes through the point, and I write it, the tangent passes through the point x and y, right? It means x equals pi and y equals 0. So the tangent passes through the point pi and 0. So from the given equation of the curve here, we can deduce y dash. Y dash equals, here we have the product of two functions, x multiply sine y, so y dash, so y dash equals the first multiply the derivative of the second function. The derivative of sine is cosine x plus the second function, it is sine x multiply the first, multiply the derivative of the first, it is 1. So y dash equals x cosine x plus sine x. And now at x equals pi, y dash equals pi cosine pi plus sine pi. And we know that sine pi equals 0, cosine pi equals negative 1, so the result equals negative pi. Okay, it is a y dash. So the equation of the tangent is y minus 0 equals the slope negative pi multiply x minus pi. So y equals negative pi multiply x minus pi. Okay, so y equals negative pi x plus pi power 2, as negative pi multiply negative pi equals pi power 2. And to get the intercepted part from y-axis, okay, here the intercepted part from y-axis, put x equals 0. So when x equals 0, we get y of 0 when x equals 0 equals negative pi multiply 0 plus pi square. So y equals y power 2. And we choose letter D.